All right, chemistry folks, today we're going to talk about a standard apparatus, then we're going to talk about Bunsen burners, and then I'm going to bust out a flamethrower, baby! Yeah! Cue that fire intro music! Okay, so now we got to talk about the standard apparatus setup. This is what we would usually use in lab. So first of all, the ring stand would be this whole thing right here. So this big pole right here, including this metal base at the bottom. So we've seen that before. Now, the large ring support would be this ring right here. The small ring support would be this guy right here. On top of the small ring support would be the wire gauze to get that even heating. And then sitting on top of that wire gauze, we'd often have our beaker. Here we go. Boom. So I'll draw my beaker. Mine kind of looks like an ugly penguin, sort of. Anyways, so that's our beaker, if you will. And our Bunsen burner, our last label, is this guy down here. A couple things I want you to note. The distance between the top of the Bunsen burner, the metal right here, and the small ring support, so that distance right here, that should be about, we'll say, 3 fingers tall. So some of us have bigger fingers than others, but generally speaking, about 3 fingers, okay, will be the height there. So how do you remove a hot beaker from the standard apparatus? Of course, we'd always use our beaker tongs to do that. And then we'd plop it on our countertop if it's a glass beaker to let it cool down slowly to avoid that heat shock. All right, kids. Now, I know the pictures on my smartboard don't always do the Bunsen burner justice, so I want to hold one up for you just to make sure you know exactly what parts we're talking about. So on the bottom here, we have the little gear that controls the gas. So lefty-loosey opens it up and lets more gas flow into the Bunsen burner. So the methane gas is increasing as I go left. As I go righty-tighty, I'm closing that valve, decreasing the amount of methane gases going into our Bunsen burner. Now the other piece of the Bunsen burner that we have here is the oxygen flow controller. It's like a big tube. You'll notice on the bottom of this guy, it's got little windows like that. So oxygen from the air can flow in through these windows as long as they're open. So the more open they are, the more oxygen. The less open they are, the less oxygen you're getting. So if I hold this up here, okay, so they're all the way open now. As I start to screw this on here, we're decreasing the amount of oxygen. If I screw it on all the way, you can't see through the windows anymore. So there's almost no oxygen getting into that Bunsen burner. So that's how you control your gas flow and your oxygen flow. So a couple things to label. The oxygen flow controller is this whole tube right here, as you just saw in the video. Okay, and the windows would be down here towards the bottom. The gas flow controller is going to be that gear at the bottom. Okay, so we're talking about this guy right there. And what gas are we using? So you heard me mention it. It's called methane gas, and its formula is CH4. So we haven't talked about formulas that much in this class yet, and we won't for a while, but I want you to know that. So methane gas is CH4. How you know when the gas is on and flowing? Well, when the handle is parallel to the valve. I also wanted to show you guys the gas valves on my desk. So notice when the gas valve is perpendicular to the handle, the gas is off. But the moment that I turn the handle parallel, you can hear gas coming out from right here. And if I connect a Bunsen burner tube to that, we follow that tube, now gas is coming out of the top of this Bunsen burner right here. And you always make sure you turn the gas off right here. You don't want to turn the gas off at the Bunsen burner, you want to turn it off at the source. Boom, so now this is perpendicular again, and the gas is off. Now down here, we're going to get a little ahead of ourselves, but there's a reason why I want you to write the chemical equation. So methane gas plus oxygen from the room will make carbon dioxide and water. And the chemical formulas for those are CH4, O2, CO2, and H2O, respectively. So methane gas is CH4, oxygen gas is O2, carbon dioxide is CO2, and water is H2O. Now you'll notice there's a big 2 right here. That's part of stoichiometry. That's unit 7. That's way down the road. Here's the take home I want you guys to have with this though. You'll notice that the ratio of methane gas, or CH4, is a 1 to 2 with oxygen. So to have a perfect stoichiometry equation here for our flame, we want 1 part methane and 2 parts oxygen gas. That's going to be important for when I show you how to actually light the Bunsen burner. Now it's time to actually light a Bunsen burner. So what we're going to do is I'm going to light this Bunsen burner. I'm going to talk to you about 3 different kinds of flames. I'm going to compare them, tell you what's wrong with the first 2, and I'm going to tell you how to correct them. So the first thing we're going to do is I'm going to go ahead and turn my gas on at the valve over here. So I turn this on. So now gas is traveling through this tube and up to the tip of this Bunsen burner right here. So I'm going to use this sparker. It's called a striker. So it creates little sparks like that. So I use that to light my flame. All right, so the first flame we're going to have here is called the birthday candle flame. So the birthday candle flame is bright orange, and it's considered not hot for a flame. That doesn't mean that if I put my paw in here, it won't get burned. It definitely will. What I mean is it's not hot for a flame. It's cooler than other flames, okay? So the problem with the birthday candle flame is that it does not have enough oxygen. The windows down here are closed, and so oxygen from the air can't get into the Bunsen burner, and so this flame needs more oxygen. Okay, so as you just saw, the birthday candle flame is orange, and it is not that hot, relatively speaking. It needs more oxygen. So that's the problem with the birthday candle flame, is it needs more oxygen. So if I open these up a bit, we'll get something that looks like this. This is called Big Blue. Big Blue. It's pretty, look how tall that is. That's crazy. Big Blue flame. Now the Big Blue flame is hotter, but it's not hot enough. We're getting closer to that nice 1 to 2 ratio of methane gas to oxygen gas, but we're not quite there. Big Blue, that second flame you just saw, okay, it's blue in color, shocker. And it's hot, but not hot enough. So it's hotter than birthday candle, but it's not quite there. Part of the reason why it's hotter is because it's closer to the perfect ratio, but we can do a little bit better. So this is where you have to do a little fine tuning with your gas flow controller and your oxygen flow controller until you get something that looks like this. Okay, so this is the perfect flame. So the perfect flame is the hottest by far, and it has a perfect ratio of 1 part methane gas, 2 parts oxygen. And here's how you recognize when you have a perfect flame. It's when you get this perfect little inner blue cone right here. Okay, you guys can see this right here. Perfect inner blue flame. It should be about 1, 2, 3 fingers tall, right there. Okay, that's how you recognize it. And the hottest part of this flame is actually right there at the tip of that inner blue cone, And this is a perfect ratio of 1 part methane gas to 2 parts oxygen gas. So that's how you diagnose your flames and fix them. Now, of course, as I wrap this up, I don't want to turn this off at my Bunsen burner. I want to turn it off at the gas right here. So if I take this valve, turn it perpendicular, so gas is no longer going through this tube, and we come back up here, and we notice, the flame has gone out. So that's how you properly shut off your Bunsen burner. And then the perfect flame, it's very hot flame. It's got that perfect ratio, 1 part methane, 2 parts oxygen. That's why it gets so hot. And it must be 3 fingers tall and have a sharp inner blue cone. Okay, so here's a nice picture of a perfect flame. And as I just mentioned, the flame is the hottest here in zone B at the tip of that inner blue flame. don't forget that this distance right here should be 3 fingers tall. Now let's get to that flamethrower. All right, kids. Now to send all these points home about the Bunsen burner you just learned, I got myself a flamethrower. Yeah, there we go. So right now we got ourselves the perfect birthday candle flame. It's orange because it's a nice cold flame that doesn't have a lot of oxygen in it. And remember, when I say cold, I mean cold for a flame. My paw would get severely burned in there, all right? Now, if I open up my oxygen windows down here, I can get closer to that perfect ratio of 1 part methane, 2 parts oxygen gas. Let's try that. There we go. Woo! Now we got a perfect blue flame. Amazing. We have the nice ratio. This is a much hotter flame. For funsies, I can close those oxygen windows, and we'll get that birthday candle back here in a second. Come on, buddy. Come on. There it is. And if I'm really feeling fun, I can crank up, the gas a little bit, make it a little bit taller. So not enough oxygen, make the perfect ratio. Whoa, all right, there we go. And I got a perfect blue flame there. Loving it. And the last thing you can do that's pretty sweet is if you take out all the gas together, you can do this. Yeah! Went down the tube. It was awesome. Bunsen burner, baby. Flamethrower!